So today we're going to talk about slope from a situation, and what that means is if you're given a word problem, how are you going to know what the slope is in that situation? So first of all, there are some words that tell us that we're dealing with slope. Okay, so one of the first phrases that we see that means slope is every. So for example, you might see every 5 seconds 2 people hike down a mountain or 2 people buy a car. I don't know what they're doing, but every something people are doing it. When we look at slope, I don't want to know every 5 seconds 2 people. I want to write that 5 seconds, 2 people per 5 seconds, and then I would rewrite that as a rate. So I would write, for this one, I would write people per second, so I would write 2 over 5, and then if I could, I would reduce that. And that would be it. And I could also write that as 0.4. Okay, so that's one that we might see. Every tells us that we're seeing some kind of repeated value. Okay, another one that we might see is per. So for example, the rate in barrels per hour. And this per, so like think about it like this. If you were to look at a situation like this, you might see, so I would think of this as a fraction. Barrels, and then this is like our fraction bar. Per is the fraction bar. Hour. So the per tells me that I'm dividing. The first one divided by the second one. That's my rate, that is my y depends on x, my y per x. Okay? So this is my y, and that's going to be my x, barrels per hour. Similarly, each, 2 pounds each month, pounds per month, pounds each month. So I would write 2 pounds each 1 month, which is 2 for my slope. Okay. Another one we might see is a steady rate. So at a steady rate of 3 miles every 3 minutes. Okay. So in that case, miles every minute, which is kind of like this one. Every minute we go 3 miles. So we have 3 over 3, which gives me a slope of 1. Okay. Here's another one, for 1. He charges $5 for 1. 5 out of 1 equals 5, and that would be my slope. Okay. So that is something, those are words that tell me I'm dealing with slope. Now, I know we haven't talked about this yet, but it's so easy, I really wanted to go over it. When we look at an equation, okay, in an equation, the slope is the value before the x. So literally, you look at whatever's in front of the x and circle it, letter and like number and sign. So see right here, there's a -3 in front of it, so the slope is -3. Here there's a 7 in front of the x, so it's -7. Now for this one, I don't have it written in the same order, but I'm still looking at what's in front of the x. So I'm going to take the number and the sign. So it's -0.6 is my slope. Likewise for this one. Now let's pretend, just for the heck of it, let's pretend that this one is positive 2/3. Okay, then my slope would be 2/3. Because it's the number and the sign. So 2/3, positive 2/3 is going to be my slope. So for this one it's -3, positive 7, -0.6, positive 2/3. Okay, so that's how we can tell from a table or an equation whether or not we're dealing with slope. All right, so now we have the situation here, and we're going to do the situation in our notebooks in your practice spiral, because this is the first problem on tonight's homework, and there's not enough room to do the work on the paper. Okay, so when we look at this problem, all right, we see 3 seconds, every 3 seconds 4 cubic feet of water pass over a dam. This phrase right here, because I see every, that's telling me that I've got, that's telling me that I'm looking at a slope or a unit rate right there. Okay, so I'm going to actually fill this in. So 3 seconds, 4 cubic feet of water. That means 6 seconds will be 8 cubic feet. 9 seconds will be 12 cubic feet. 12 seconds will be 14 cubic feet. Okay, I did that because I'm going up 3 on this side, 4 on this side. So every 3 seconds, 4 feet of water. 4 cubic feet of water pass over a dam. Okay. Now, if I plot these points, I'm going to go over 3, up 4, over 6, up 8, over 9, did I do that right? Yes, over 9 up 12. I'm a challenged grapher, y'all. Over 12 up 16. Okay, so there's my points. We'll talk about data type later, but these points can be connected, and this is the only thing I have to draw a line with right now, so this is what I'm drawing it with. Okay. Okay, so I'm drawing this line right here, and I can, now they're asking me to find the slope. I can find the slope in a whole lot of different ways. I could do the rate of change, which is my delta y, my delta y over delta x. Okay, 4/3. I could look at my rise over run. I'm rising 4. I'm running 3. Rise over run is 4/3. Or I could pick 2 points like we just got done doing. I could say, okay, I have a point at 0, 0, and I have a point at 3, 4, x1, y1, x2, y2. I could do 4 minus 0 over 3 minus 0, which is 4/3. Either way, no matter how I do it, I get the same slope. They're all going to give me the same answer. So when they ask me what the slope is 4 over 3, which means 4/3 of a cubic foot of water per second. Okay, water passes over the dam at a rate of 4/3 cubic feet in 1 second, which is exactly what I wrote there. So if they're just asking for the number, they give me this. But when they ask me what it means in the situation, I have to describe it in terms of this situation here. So what does that mean? It means 4/3 of a cubic foot, or 1 1/3, if you like it that way, 1 1/3 cubic feet in 1 second pass through the point. Now, pass over the dam. Okay, so now it says, what does the point 4.56 represent on the graph? So if I look at 4.5, I don't know what I'm saying, but whatever, 4.56. So 4.5 is time. Okay, so x is time. I can see that from here, and I can see it from here. And 6 represents seconds. What that means is that after 4.5 seconds have passed, 6, oh, I'm sorry, volume. This is volume. Sorry about that. 6 cubic feet of water passed over the dam. Okay? So it says how many cubic feet of water would be expected to pass over the dam in 10.5 seconds. Well, if I go over to 10.5 seconds, looks like it's about 14 seconds. I mean, about 14 cubic feet. I could also continue, well, I'm sorry, that's 16. I don't even know what's happening there. If I continue this, between 9 and 12 is 10.5. Between 12 and 16 is 14. I don't know why I put a 14 there. I'm sorry, y'all. Yeah. Okay. So then it says, in how many seconds will 10 cubic feet of water pass over the dam? Again, I can go right here. Between 8 and 12 is 10. Between 6 and 9 is 7.5. So about 7.5 seconds. Okay. Now, next unit, when we actually start doing stuff in slope-intercept form, we're going to learn some more precise ways of finding these values. Okay, but for now, those are acceptable answers. You're going to continue to practice this. You're going to practice a bunch of examples, and hopefully you'll start feeling really good about this.